Today, we're going to solve a very practical problem. Let's say you've already generated a video, but now you want to add a side angle shot. Recreating the entire shot would be a real hassle. So today, I'm introducing a new technique called CrossView Warp. It preserves the original performance while repositioning the camera somewhere else. We can even make the camera move along a path. We design and turn it into a complete camera animation. We've covered a similar feature before, but what we're looking at today is the upgraded version of CrossView. Here's the original video, and here's the same video after moving the camera to the side. Now let's look at a continuous camera move. The character keeps talking while the camera rises from the front and slowly moves around to the side. To use this technique, you first need to install a ComfyUI extension called CrossView Warp. Clone it into ComfyUI's custom nodes folder, then restart ComfyUI. You'll also need several additional extensions. The most important one is Depth Anything V2 because this model relies heavily on depth maps to understand and represent the spatial relationships in the scene. Finally, download the corresponding CrossView Warp LoRA and place it in your LoRA directory. For easier testing, I've also built the workflow on Running Hub. In the ComfyUI space, Running Hub is a great online working platform because whenever new models or extensions are released, the platform usually adds support for them very quickly. Running Hub also provides an online community for ComfyUI creators where you can find plenty of creative inspiration and example workflows. The overall structure is essentially an LTX 2.3 IC-LoRA workflow. It has two stages. The first stage generates the base video, and the second stage upscales that video. For the main model, we're using the distilled LTX 2.3 model provided by KJ. And don't forget to load the CrossView Warp LoRA through the IC-LoRA loader node. The workflow may look like it contains a lot of nodes, but there are really only three parts you need to understand. The first is the original video. The second is the most important custom node, CrossView Warp, where all the camera settings are configured. The third part consists of two IC-LoRA guide branches. Normally, an IC-LoRA workflow only uses one guide, but this workflow uses two. After the reference video is resized, it passes through two separate branches. In the first branch, we use the original video directly and feed it into the sampler through LTX and video guide. This branch mainly tells the model who the character is and what action they're performing. The second branch is a little more complex. First, we process the reference video with Depth Anything V2 to generate a depth map. That depth map is then sent into the most important node in today's workflow, CrossView Warp. I'll explain exactly how to use this node in a moment. It ultimately generates a video that looks a little strange, almost as if the image has been torn apart. The character and background are pushed into new positions, and you'll also see a lot of pink areas around the edges. Those pink areas are not errors. They represent regions that are visible from the new camera position, but were never captured by the original camera. LTX 2.3 then needs to generate the missing details in those areas. There are two ways to write the prompt. The simplest method is to use the trigger word CrossView. The second method is to describe the content that wasn't visible in the original shot. In other words, you can describe what should appear inside those pink regions, since the model needs to imagine and reconstruct that missing content. Both video streams we just generated are then sent into LTX at video guide. Their parameters are basically the same. The only difference is that one receives the original video, while the other receives the depth warp video. This two-guide structure is what makes the workflow special. The later sampling and upscaling stages are very similar to the original workflow, so you can process them using the same settings you were already using. Now, let's take a closer look at the CrossView Warp node. The first thing you'll see is a sphere with something resembling a matchstick at its center. The camera viewport points toward the center of the sphere. We can drag the sphere to change the overall viewing direction. This control has two main functions: changing the camera position and creating camera animations. Let's start by changing the camera position. First, locate the camera. This object here is the camera, and we can drag it to reposition it. You can place the camera to the left, right, above, or below the subject. However, pay attention to the colors on the sphere. You'll see green regions, yellow regions, and gray regions. You can think of these colors as representing the camera positions that appeared in the training dataset. Green positions are relatively reliable. Yellow positions are viewpoints the model has seen, but it has less confidence in them, so they may produce some problems. The gray regions are completely outside the training range, so I don't recommend moving the camera there. Also, pay attention to the mouse wheel or middle mouse button. Scrolling it changes the distance between the camera and the subject. Now let's test the results from the different colored regions. Our first source video shows a person arranging flowers. We'll change the viewpoint while keeping the camera inside the green region. We'll test 4 directions: left, right, above, and below. Here are the left and right views. Overall, the results look excellent. The character consistency, the character's movements, and the way the environment is revealed are all very good. Now let's look at the upper and lower viewpoints. The adjustable range is smaller in these directions. The overhead view is quite noticeable, while the low angle view is more conservative. Next, let's test the yellow region. The original video shows a beautiful woman reading in a library. This time, we'll move the camera into the yellow area and test 4 diagonal directions: upper left, upper right, and lower right. As you can see, the left and right movement is still very obvious. The sense of depth between the chandelier bookshelves and character becomes much stronger. However, when we move the camera downward, one result doesn't show a clear change. The other does produce a lower camera angle, but the character and the surrounding space also begin to be reinterpreted. This confirms what we mentioned earlier. The yellow region is more of a creative zone, and it isn't as reliable as the green region. The image may feel more dramatic, but you also have to accept that the model is more likely to improvise. So how do we create a good video with a convincing camera angle change? The most important factor is whether the depth warp video can represent the scene's spatial information clearly. Let's run a few special tests to see where this works and where it starts to break down. In the first test, the character isn't facing the camera directly. The body is already angled slightly to the side. We move the camera to the edge of the yellow region on the left, and the new viewpoint is still very obvious. The reason is that the depth warp video successfully communicates the overall depth information and spatial structure. The second test is more complicated. The original video shows a beautiful woman in a hotel lobby. Notice that the shot already contains movement, including its own camera motion. Once again, we move the camera to the far left edge of the yellow region. In the generated result, the overall spatial structure is fine, but the character consistency is noticeably lower. Now let's look at a 2-person example. In the original video, a beautiful woman is speaking while another person has their back to the camera. We move the camera toward the left edge of the yellow region to an angle of about 65 degrees. This time, the generated depth warp video loses the spatial relationship between the 2 people. Under these conditions, the final result doesn't look significantly different from the original video. Next, let's see what happens when the character isn't positioned in the center of the frame. The original video shows a beautiful woman listening to a vinyl record, with the character positioned close to the edge of the image. Once again, we move the camera to the left edge of the yellow region. The final result does show a very obvious switch to a new viewpoint, but the character consistency drops significantly. This is because the node is more likely to assume that the main subject should be positioned near the center of the frame. Now let's look at a completely failed example. This IC-LoRA does not work with vertical videos. Our reference video shows a beautiful woman dancing, and I've again moved the camera to the edge of the yellow region on the left. As you can see, the final output shows almost no effect at all. So when choosing your source video, remember 3 basic rules. First, use a horizontal video. Second, keep the main subject near the center. Third, make sure the original camera is relatively stable. Footage that meets these conditions allows the depth warp video to represent the spatial relationships more clearly, which leads to a higher quality second camera result. Besides changing the camera position, what else can the CrossView Warp node do? It can create complete camera animations by adding keyframes inside the sphere. To add a new keyframe, simply right-click. You can then use the left mouse button to adjust the position of any keyframe. To delete a keyframe, hold Shift and right-click it. Notice that there's a number in the center of each keyframe. You can think of this as the keyframe's position in the sequence. The original video we're using is the same stable, static camera shot you saw earlier. Here's the corresponding depth warp video, and here's the final result. Pay attention to the sofa and wall behind the character. Instead of instantly jumping to another angle, the The camera slowly rises from the front and then moves around to the side. The character's performance continues while the camera completes an entire movement. How the camera travels between keyframes is mainly controlled by two parameters. The first is interpolation, which determines the spatial path. There are usually two options. Linear creates a straight line path, while smooth creates a flowing curve. The second parameter controls the speed and pacing. If you've done a lot of video editing, this part should feel familiar. In this example, I've set the spatial curve to smooth and the speed curve to easy in out. Here's the final result. The camera rises first and moves into an overhead view, then slowly returns toward the character. The circular rug, lantern, and handpan make the changes in spatial perspective especially clear. Now let's see whether CrossView can add a new camera path when the original video already contains its own camera movement. We'll return to the hotel lobby scene we saw earlier. Notice that both the character and the original camera are already moving. Here's the generated depth warp video, and here's the final result. The character shifts from a mostly frontal view to a profile view, and the pillars and lobby in the background show clear parallax. However, this is more difficult because the original video already contains one camera path, and we're adding another one through keyframes. If both paths move in similar directions, the result can feel much more dynamic. If their directions conflict, you may run into problems. Let's look at a second example. This scene features a woman in traditional clothing standing in a grove of cherry blossoms. There's a distinctive moment where cherry blossom petals drift across the front of the character. I designed a more complex camera path for this shot. In the final result, the new camera movement is clearly visible. More importantly, the falling cherry blossom petals we just mentioned are also preserved. To sum it up, CrossView Warp isn't best used to turn a video into a fully three-dimensional scene that you can rotate however you want. What it really gives us is a chance to create an additional take from another camera position. That's all for today. Follow me and become someone who truly understands AI.